Today we are going to look at the division properties of exponents. And so let's take a look at the first problem here. Here we have an a to the fourth, c to the second over a to the third, c to the fifth. Well, the rule is that we can just subtract the exponents, and let's see why that's the case. So if I was to write this out in an expanded form, I would have 4 a's on top of the fraction, and then 2 c's also on top of the fraction. That's what a to the fourth, c to the second is. Down below I have 3 a's on the bottom and 5 c's on the bottom. And the way I like to do this is just take the difference and see where the more a's are, the more c's are, and that's where they are in the fraction. So let's take a look at what I'm talking about here. If I cancel out the a's on top of the fraction and some on the bottom of the fraction, see how there are more a's on top. So if I subtract 3 from 4, I'm left with 1a, and it's on top of the fraction. And so that's what I'm going to do. I'm just going to take out those 3 a's away from the bottom and take 3 away from the top, and you see how I'm left with 1a on top. Same thing with the c's. You see how these c's will cancel out, and what I'm left with are 3 c's on the bottom of the fraction. That's what I can do here as well. So I can take away 2 c's from the top, which is what I did, and I take away those same 2 c's on the bottom, and I'm left just with 3 c's left on the bottom of the fraction. So our answer would be a to the first power over c to the third power, or just a over c to the third power. So we'll be doing that with this next problem, and this has lots of x's and y's, so I wouldn't want to have to write it out longhand like I had done over here. I would just visualize it. See, here I have 8 x's all being multiplied. Down below, I've got 6 x's. So I've got more x's on top. That's why when I cancel out the 6 x's from the bottom and 6 x's from top, I still have 2 more x's left on top. So there it is. X to the second is on top of the fraction. If I look at the y's, well, I've got 5 y's on top, but 10 y's down below. That means I have more y's on the bottom of the fraction. So when I cancel out those 5 y's from the top, and I take away 5 y's from the bottom, I'm still left with 5 y's. So I have y to the fifth power on the bottom. Same thing with the z's here. See how I only have 1 z on top? If there's no exponent, you can always put a 1. Well, I'm going to take away that 1 z from the top, take away 1 from the bottom, and you see how you're left with 2 z's on the bottom of the fraction. So we can rewrite our answer. We've got 2 x's left on top, and for the y's, we've got 5 y's on the bottom, and we had 2 z's left on the bottom as well, and that would be our answer. Well, this next problem involves a coefficient, and so with coefficients we don't subtract, we reduce. So what I want you to do on this problem is think of it as 3 separate problems. So we have the 15 over 10, that's one problem. We have the x to the third over x, and then we have the y squared over y to the sixth. So I look for a common factor here. The common factor is 5, so that's what I'm going to do. I'm going to divide by 5 on both the top and the bottom of the fraction. And so when I do that, I'm left with 3 over 2. Now I leave some room on this fraction bar because I'm going to have some x's and some y's left over as well. So let's take a look at the x's. So here I have 1x on the bottom. That's going to cancel out 1x on the top. And so what I'm left with is just 2 x's on top of the fraction. And so I can rewrite that as x squared right next to the 3. Now let's take a look at our y's. So here we've got 2 y's on top, which are going to cancel out 2 y's on the bottom. So I know the y's are going to be left in the bottom because there's more y's on the bottom than there are on the top. So how many are left over? 4. When you take 2 from 6, you're left with 4. And so that's what we have on the bottom of that fraction. We just, right next to that 2, we write y to the fourth power. And there's our answer. And it's all reduced for us. Well, the next one is similar to the last, just more parts, I think, to it. So again, the same sort of thing. What we want to do is treat it as, in this case, 4 separate problems. So we've got the coefficients first. So I'll think of those numbers, and then I'll look at the x's, and then the y's, and then the z's last. So starting with the coefficients, I see that 2 goes into 2. So I can divide this by 2 and divide the 14 by 2 as well. So what's left over? Well, we've got on the top of the fraction a 1, on the bottom of the fraction a 7. And so looking at these numbers here, I've got a 9 x's on top, looks like 2 x's on the bottom. So I'm going to cancel out those 2 x's on the bottom. Take away 2 x's from the top, leaves me with 7 x's left over on the top of that fraction. Now looking at the y's, there's only 1 y on the top. Well, I'm going to cancel out that 1 y on top and take away that one of those y's from the bottom. And that leaves me with 3 minus 1 makes 2 y's left on the bottom of that fraction. And now we look at those z's. Well, this is an interesting situation. These 8 z's are going to cancel out these 8 z's. So there's no more z's left over. And so if you canceled all those numbers out, it'd just be 1. But 1 doesn't change anything when you multiply by it, so we don't need to write it. And so what are we left with? Well, 1x to the 7th is just x to the 7th power. And then down below we still have that 7y squared. Well, so far we've dealt with just division problems. So these next few problems involve a power raised to a power. So we've got the power on the outside of the parenthesis. And we've seen this before when we were dealing with properties of multiplication. But here we'll have some division involved as well. So the thing to remember is that if you don't see an exponent, it's always 1. And then the rule was to multiply that exponent on the outside by each of the exponents inside. Because what it represents is 2 groups, the opposite of 2 groups of 3 to the first power, opposite 2 groups to 4 to the first. And so we go ahead and do that work. I'm left with 3, and then to the 1 times by negative 2. Down below, 4, 1 times by negative 2. So I'm multiplying the exponents when the exponent's on the outside of a parenthesis. We do that work, we get 3 to the negative 2nd over 4 to the negative 2nd. Well, the common mistake is people want to multiply out 3 times 3 and say the answer is negative 9, but that's not the case. When we have negative exponents, we're going to take the reciprocal of those negative exponents. And we talked about that 2 days ago, so if you look at lesson 67, that will have that concept there. Same thing over here, we got negative exponents. Let's take their reciprocal. And so when we do that, those exponents become positive. So it becomes a 4 squared over 3 squared. Then you can multiply out those 4's, we get 16. Multiply out the 3's, you get 9, and we've got our answer, 16 ninths. Well, we'll see the same sort of thing on this next problem. Difference is there's more parts to it. So again, if you don't see exponents, put an exponent of 1. And then when the exponent is on the outside of a parenthesis with a power raised to a power, we're going to multiply. But the trick is you got to multiply every exponent in the parentheses by the one on the outside. That includes this 3 down below. So we go ahead and do that work, and this is what we've got. 2 to the 1 times by negative 4 times by x to the 1 times by negative 4. And down below that we've got y to the 3rd times by a negative 4. So you do some work there, and we've got a 2 to the negative 4th power, x to the negative 4th power, and down below we've got y to the negative 12. Well, everything's negative. All those exponents are negative. So whenever you have negative exponents, we just take all those numbers in this case, and they go down below. Do the same thing with these. All these numbers go up top. And we can rewrite it. So what we've got now is a y to the 12th power over 2 to the 4th x to the 4th. Well, the last step would be just to multiply out those 2's. So if you multiply out the 2 times the 2 times the 2 times the 2, that gives us 16 altogether. So what do we have as an answer? Well, y to the 12th over 16x to the 4th power. And there's our answer. Well, the next part is going to have some more problems using that concept of a power raised to a power and some more negative exponents as well.